This is the third video for Section 4, Chapter 1 of your trigonometry book. This video is going to be a little bit heavier on information than the others. We are talking the ranges of our trigonometric functions, and we're going to look at the ranges of all 6 trig functions, although they actually have the same range in pairs, so there's really only 3 possibilities. So to do this, we're going to be looking again at our general angle and standard form that forms a right triangle with x and y for legs and r for the hypotenuse. Now keep in mind that because that is a right triangle, the r value, the hypotenuse, is the longest side. It has to be. Which means that when we look at a value like sine, which has y over r, y is always smaller than r. In other words, this fraction, y over r, will have an absolute maximum value of positive 1. And that would be when we are on the positive y-axis and y and r are the same value. Y is never going to be larger than r. It can't be because r is the hypotenuse. And if the bottom number in our fraction is bigger than the top number, or the top number is not allowed to be bigger than the bottom number, it can only be equal to it, then that fraction will always have a value less than or equal to 1. Now the other possibility is that y and r could have different signs, which means that this fraction could be negative, which means that y over r will also always be greater than or equal to negative 1, which means that the fraction y over r is always between negative 1 and 1 inclusively. Now I wrote that in what's called interval notation, but what that says is that sine theta must be between negative 1 and positive 1 inclusively. Okay, in other words, sine is always less than or equal to 1 and greater than or equal to negative 1. Now cosine is the exact same argument. X is also a leg on that right triangle, which means that x is never going to be larger than r. It is possible for x to equal r, but it is not possible for x to be greater than r. So x over r would have the exact same constraints. The cosine of theta is always between negative 1 and 1 as well. Okay, so cosine is always less than or equal to 1 and greater than or equal to negative 1. Now we can make these exact same arguments for all 6 trig functions and their fractions, comparing y and x, y and r, x and r, to each other and considering the values. But I think that the best way we could do this is we could just create a reference item that references the ranges of each of our 6 trig functions. So like I said, they come in pairs. You notice that sine and cosine had the exact same range. The sine and the cosine are always between negative 1 and 1 inclusively. Now what I mean by that is let's draw it on a number line. There's a closed circle at both negative 1 and 1, and we can only exist between those 2 circles. Okay? Now I'm going to write that in 2 other ways, in both set builder notation and interval notation. So set builder notation, which you might be familiar with from depending on who you had for Algebra 2. We would state y, and then this symbol means such that the absolute value of y is at most 1. And then in interval notation, that's what we wrote on the previous page. Remember that in interval notation, a squared bracket means including. So it includes both -1 and +1. Tangent and cotangent, those are, y over x and x over y. So there really are not any restrictions necessarily on values of x and y, which means that the range of tangent and cotangent is all real numbers, or the real number symbol. Okay, so in set builder notation, we would say the set of all y such that y is an element of the real numbers. That's what those symbols mean. In interval notation, we would use a curved bracket, and we'd be looking at every single value from positive infinity to negative infinity. Remember that with infinity, you always have to have a rounded bracket in interval notation. Finally, secant and cosecant. Remember that secant and cosecant are the reciprocals of cosine and sine, respectively. So if sine and cosine have to be between -1 and 1, secant and cosecant would be outside of -1 and 1. So this is a little bit harder to write in words. We would write this as greater than or equal to 1, or less than or equal to -1. And again, I'm going to draw that on a number line so you can see what I'm talking about. We're going to have a closed circle at -1, and we're going to shade out, including the arrowhead because it goes on forever. And we're going to have a closed circle at +1. We're going to shade out, including the arrowhead. So all the numbers outside of -1 and 1. In this case, for set builder notation, we would say the y such that the absolute value of y is at least 1. So the big change there is instead of at most, this symbol means at least 1. And then the interval notation is actually harder to write. We have two different intervals. That's part of the reason why. We have the interval from -infinity to -1, including -1, square bracket, or, that's what this symbol means, 1 to positive infinity. Remember that with infinity, we can't include infinity because it's not a set value. So we have to use the rounded bracket. Now that's pretty heavy stuff, guys. So this is something where if you have questions, you need to make sure you're asking in class. You can also email me and I'll do my best to clear it up if you don't want to ask in front of the class. Admittedly though, or you could come see me after school. I mean, you need to get these questions answered. It's very important that you understand that sine and cosine only exist between -1 and 1. That tangent and cotangent exist everywhere, range-wise, and secant and cosecant, their range is outside. It's less than -1 or greater than 1, inclusively. All right, so let's do an example of what we're going to have to do with this, and then we'll wrap up this video and go to the next one. Here's the kind of problem that you're going to have to do with this information. It says, decide whether each statement is possible or impossible. So what they're saying is here is a value for the range of these various trig functions. Is it possible for that value to exist? So for instance, is it possible for the sine of your angle to be 2.5? The answer would be impossible, because sine only exists between -1 and 1. 2.5 is not between -1 and 1. Okay, tangent value of 110.47. Well, there are no restrictions on tangent or cotangent. Meaning that as long as your number is a real number, it is possible to get that value. Okay, number 3 says secant is equal to 0.6. Well, that would be impossible, because secant must be between, or not, cannot be, but sorry, I said that wrong. Let me say that again. Secant cannot be between -1 and 1. It has to be outside. It cannot be between -1 and 1. And 0.6 is between -1 and 1. Finally, on number 4, cotangent. That is, doesn't matter what that value is as long as it is a real number, because cotangent of theta can be any real number. And that's what you have to be able to do with this information at this point. That wraps it up for this video. We are going to do, I believe, 2 more videos in this section, so on to video number 4.